Now that we understand the equations for all of these different forms of conics, so ellipses, parabolas, circles, hyperbolas, this is actually a rational graph, a horizontal parabola, and we have a line. We're going to be looking at systems of equations, which may be nonlinear, as well as a system of inequalities. So those are greater than and less than. And in those situations, our solutions are going to have a set of values for the answer. So where do lines, parabolas, circles, ellipses, hyperbolas, rational equations, other types of polynomial equations, logarithmic equations, any type of equations, where do they intersect? What are the solutions to where those two equations are the same? So the solutions to nonlinear systems of equations can be found using substitution or the elimination method, which you should have learned about in your algebra class. So the main thing here is the substitution method is preferable, or it's easier to use, if the equation is linear. If one of them is linear, like here we have a line, it's easy to isolate one variable and plug it into the other. However, most of the problems or the systems of equations that you will be solving in this section, it's going to be preferable to use the elimination method. And that'll be because we have maybe both an x squared and a y squared. Now, there is one situation that I want to talk about. So here we have an ellipse, it appears, intersecting with a parabola. Now, how many possible solutions will I be able to find here? Well, you can clearly see there are 4 possible solutions. And that would be the max number of real solutions. Visualizing this, I could have an ellipse and a parabola that intersect, and what you see here is 3 solutions. So we've got 2 individual solutions, and then here we've got this tangent solution. This is actually going to be a solution of multiplicity 2. So we would still be coming up with 4 solutions, 1, 2, and then this multiplicity 2 solution, that would be my repeated solution, so 3, 4. All right, we could have a situation where it intersects like this. And you see here we have an ellipse and a parabola, and there are only 2 real solutions, but we have to be able to find 4. So in this situation, you would get 2 real unique solutions. Unique just means they're different, and 2 complex solutions, which are unique. There will be 2 different complex solutions. Moving along, we could have an ellipse and a parabola that maybe intersect like this. So it appears there's only 1 real solution. In this situation, we would have 1 real repeated solution, a solution of multiplicity 2, and then 2 complex unique solutions. And the last situation that could occur if we had an ellipse and a parabola would be that they don't intersect at all. No real solutions. So in that situation, we would have 4 complex or imaginary, unique, all different solutions. So the point here is that you are always going to be trying to think about, well, what is the maximum possible number of intersections I could have? Because that is how many solutions you will be required or you'll need to find. So if you had an ellipse and a parabola, you could end up with all of these different types of situations. Let's look at an example. In this example, we're going to solve this system of equations. We have x squared plus y squared equals 25, and 3x minus 4y equals 0. Our first step is to identify what each of these graphs may look like. And we should quickly identify that this first one, x squared plus y squared equals 25, is a circle. It's a circle of radius 5. And then our second equation, that represents a line. 3x minus 4y equals 0 is linear. We do not have any square terms. So let's think about, at the very most, we could have a circle and a line intersect, and we would get two real solutions. That's the most possible solutions I could come up with. However, I could have a circle and a line that intersects at, say, a tangent point. That would give me one real repeated solution, or a circle and a line that don't intersect at all. So in this situation, we would have two unique complex solutions, two different complex numbers for our answer. In all of these situations, though, essentially there are two answers, two real, one which is repeated, multiplicity 2, or two complex. So as I said, when we are dealing with a line as one of our equations, it's really preferable to use the substitution method. So I'm going to say 3x minus 4y equals 0. I'm going to isolate one of the variables. It's very easy for me to say 3x equals positive 4y. It doesn't matter which variable I isolate. In this case, I'm going to divide both sides by 3, and I have that x equals 4/3 y. So I'm going to take that x equals 4/3 y, and I'm going to substitute it into the other equation. So x squared plus y squared equals 25. I'm going to plug 4/3 y in for my x value. So that gives me 4/3 y. We'll have quantity squared plus y squared equals 25. So we use the substitution method, and then at this point, it's just a matter of solving for our variable y. So it's going to be 16 over 9 y squared plus y squared equals 25. 16 ninths plus 9 ninths, 9 ninths would be equal to 1, is going to give me 25 ninths. So now I have 25 ninths y squared equals 25. Multiplying by that reciprocal, I get y squared equals 9. And using the square root principle, I've got y equals plus or minus the square root of 9, or rather y equals plus or minus 3. I have two unique real y values. So now that I know these two y values, I need my corresponding x values. Keep in mind that I know what x is in terms of y. So if I take those up here, I can say, well, when we have y equals positive 3, then x equals 4/3 times 3, or 4, gives us one ordered pair. X is 4, y is 3. And then repeating that with negative 3, if we've got y equals negative 3, then x equals 4/3 times negative 3, or negative 4. So my x value is negative 4, and my y value is negative 3. So we write our 2 points of intersection, our two solutions, as ordered pairs. One thing to keep in mind, I did find my y value first and then my x value. So a common mistake I might expect to see a student make would be to write that answer in the reversed order, say 3, 4 instead of 4, 3. And that would be y, x. But these are ordered pairs, and when you're dealing with an ordered pair, it's going to be x, y. So that's the general idea of how we solve these systems of equations and determine those points of intersection. This is a really just a basic algebra strategy that we want to be able to deal with because it's going to carry through the rest of our math classes. So in this video, I should say, we did one example. We used the substitution method, which should be fairly review, to find 2 points of intersection. And then we talked about the quantity of solutions, finding that maximum quantity, and knowing how many solutions your answer will have. All right, so that's it for this video. In the next video, we're going to do some of the elimination method examples.